Okay, so surely we don't have time for question in this one. And for our fifth speaker is Gershon Celniker, who manages an R&D lab group at GM. He has academic roots in bioinformatics and machine learning applications, and he has fellowships with the Weizmann Institute and Tel Aviv University. He holds a BSc and MSc degrees from the Technion and the Hebrew University, and today he will talk about understanding and modeling gaze patterns in automotive environments.
All right, can you hear me? Nice. All right, so a little bit about myself. I'm a lab group manager at GM. GM, General Motors here in Israel, we have a technical center, quite big, 850 employees. And we're working on autonomous, semi-autonomous vehicles, level 2, level 3. And I will talk a little bit about the human eye, core principles on understanding the eye gaze and the modeling, and our data set, and some really, really briefly free research work that we recently published. Okay, so a little bit about the human eye. So we have the peripheral system and we have the fovea. And you can see, here you can see with my mouse, that the number of receptors are very, very focused. 99% of them are here in the fovea area. And the peripheral, it's very, very low density per square millimeter. So it's very, very important. And the periphery is low resolution, and it guides the fovea to the important part. So this movement between the two stages is very important for us. And here we can see the silent C map of a vehicle. We can see the dashboard, and we can see here the area of the infotainment, and of course the road. And the switch between the relaxed mode and while the driver is driving, there's the workload. It's very, very important because the fovea moves to the important area, and this is what we want to learn, and we want to model it. So we're modeling the eye gaze basically for driver monitoring systems. We want to understand the driver's state, what is his cognitive state, emotional state, what is his attentiveness, and the situational awareness of the road. Especially, it's very important during autonomous vehicles. So L2, someone is driving right now in the car, and he's very, very relaxed. He doesn't need to pay attention too much because his L2 or L2 system, sorry. But suddenly he needs to take over control, and he needs to make sure that he has situational awareness, and he is able to do that in L2 in 1 second. So it's quite challenging. We build a huge data set. Huge, well, it's 70 hours total of driving, but it's a special one. And the big advantage of this data set that we have the eye gaze of the person, and we also have the perception sensors and the cameras. So what we can see here, for instance, we have the driver. So we monitor the driver. We have in-cabin camera and the eye gaze. But we also have all the perception cameras and sensors. So we can see exactly the context of the ride. We can learn from that a lot. And now I'm going to jump really, really quickly to 3 of our publications. And if you want to have more details about these publications, you can just look for these articles. They're all published. They're all published in the last 2 years. So we'll start the first one. We have the relaxed condition, and we have the workload condition. And you see, both of them look quite the same. They look very, very condensed, and it's oval shape. But once you subtract between the two, you get something interesting. You actually get a map of reward. You get the map of importance. So in this case, what do you think the driver is doing? You can yell. I can hear you. What is driving? The driver is looking at the windshield. He's looking at the windshield, he's not looking at the infotainment, and he's looking at this area over here. That's the first paper. Second paper, we decided to take all this eye gaze information, and we clustered it. We did some clusters, and here you can see 2 interesting clusters. This one, the driver looks very, very straight, and we can see he's looking at the car ahead. And in this case, there is an intersection, and it's interesting intersection, and he's looking at these 2 cars, I think. I think he's focused on that area. So he's looking if the car is coming from here, and he's going to turn, in this case, he's going to turn left. And what is interesting about it, we took this eye gaze data, and again, we have the advantage because we know what is the driver looking at. So we have these 2, eye gaze and then the context. And we actually can detect and classify pedestrians, junctions, what kind of type of junctions, And, oh, sorry about that. Okay. And road taps, and if there is construction area or not, it's all from the eye gaze alone. And next project, and the last one. So we actually decided to, Eyal from InnoVis was just describing the importance of depth, and how important it is to understand what is the distance from us to a specific object. So we, if you have LiDAR in a luxurious car that has a LiDAR, but there are many L2 vehicles without LiDAR, and we need to do these estimations with, based only on cameras. So in this example, we decided to take the eye gaze data, so the information of the eye gaze movements of the driver, and pre-train depth estimation networks. And we decided, it was part of the brainstorming to see maybe it will work. Maybe there is something about the eye gaze of the human being that can help us to do some depth estimation. And you can see here, this is the depth estimation that we managed to detect by the eye gaze. So it's very important, it's pre-trained. So we pre-train, and then we do training on a labeled data set with specific depth. But the pre-train, it's very beneficial because it can save lots of time, and it's also, and if you want to read this article later on, we show that it actually increases the accuracy quite considerably. It doesn't move for the second one, 1 sec. Okay, maybe now. All right, so in this example, you can see there's a road, there's a warehouse in Detroit area, and we can see here quite a map of the depth, and we can see the objects that are really, really far, and we can see the closer objects. And it's all, this actually, a model is based on the eye gaze data. So these 3 examples that I showed you, they are great demonstration of how you can leverage eye gaze data into learning so many things. And the main thing in the end is the driving monitoring systems. We want to understand the driver. We want to make sure what is the driver's state, especially during this transfer of control between these different semi-autonomous modes, especially in L3 or even higher. L3, think about it, the person can read a book and watch a YouTube video, and suddenly he has 10 seconds to take over the control. We want to make sure that he's able to take over the control, that he has the situational awareness to take the steering wheel and continue driving. So feel free to contact me to learn more about it. You have the free papers if you want to read and get more information. Thank you for having me. Any questions?